I fabricated this project to depict parabolas. This is a wonderful depiction of a parabola and can very well explain about the core concept of parabolas. Now, you might wonder, what is a parabola? In mathematics, a parabola is a plane curve which is mirror symmetrical and is approximately U-shaped. It fits several other superficially different mathematical descriptions which can all be proved to define exactly the same curve. When and who created the parabola? The area enclosed by a parabola and a line segment, the so-called parabolic segment, was computed by Archimedes by the principle of exhaustion in the 3rd century BC. In his The Quadrature of the Parabola, the name parabola is due to Apollonius, who discovered many properties of the conic sections. Now you might wonder, where is it used? The reflective property is a basis of many practical uses of parabola. As you can see, this parabola is curved, and this curved parabola can be used as a reflecting mirror in automobiles, in their headlight reflectors, and it is also used to calculate the paths of ballistic missiles. They're frequently used in physics, engineering, and other sciences. Now I'll just go on to the board and explain in more detail as to what is a parabola. A parabola is a set of all points in a plane that is equidistant from a fixed point in the plane. This is a fixed point. The fixed line is called the directrix of the parabola. This is a directrix, the fixed line of the parabola and of the plane, and this is depicted with red pins. And the fixed point F is called the focus, and is represented with a green pin. A line through the focus and the perpendicular to the directrix is called the axis of the parabola. This is the axis of the parabola. It is perpendicular to the directrix and it passes through the focus of the parabola. The point of intersection of the parabola with the axis is called the vertex. This is a vertex, and this is the point where the parabola intersects the principal axis. A line perpendicular to the axis of the parabola and passing through the focus of the parabola is called the latus rectum. Now, the latus rectum's formula is 2a, and OA is not depicted clearly, but it's a black line passing through the focus and it's perpendicular to the axis of the parabola. Now, go on to the four possible orientations of a parabola. The four possible orientations of a parabola are y square, which is equal to 4ax, y square, which is equal to minus 4ax, x square, which is equals to 4ay, and x square, which is equal to minus 4ay. The y square is equals to 4ax is a present parabola which I have depicted. Y square is equals to minus 4ax is the parabola depicted over here. It opens towards the left hand side of the graph of the Cartesian plane. And x squared is equals to 4ay is a plane on which the parabola opens upwards. It's given over, it's depicted over here. And x squared, which is equals to minus 4ay, which opens downwards. The equation of a parabola is simplest if the vertex is at the origin and the axis of symmetry is along the x-axis and the y-axis. The four possible such orientations I've already given in the explanation. And I would also like to mention the lines over here, which are represented by these various threads. And these lines are P1F, which is equals to P1B1. This is a famous proof in parabolic curves to prove that this line is equals to this line. That is P1F. I'll represent P1F. This is P1F is equal to P1B1. P1B1. That means this line is equal to this line. Similarly, B2P2 is similar to P2F. This line is similar to this line, and so on. From the standard equations of the parabola, we have some observations which I mentioned earlier. The parabola is symmetric with respect to the axis of the parabola. If the equation has a y squared term, then the axis of symmetry is along the x-axis. And if the equation has an x squared term, then the axis of symmetry is along the y-axis. When the axis of symmetry is along the x-axis, the parabola opens towards the right. That's when the coefficient of x is positive and it opens towards the left if the coefficient of x is negative. When the axis of symmetry is along the y-axis, the parabola opens upwards if the coefficient of y is positive. If the coefficient of y is positive, it will open upwards, and if the coefficient of y is negative, it will open downwards. This is a project which I explained in the entire video. These are the pins which represent the points in the plane, and a collection of these pins over here, they form the parabola of the y square is equal to 4x type. The green pin over here, it represents the focus, which is a fixed point in the plane, and V, which is a vertex, is represented by a blue pin, and this is the point through which the parabola passes through and touches the principal axis. You have point C over here, represented by a white pin, and it is just a random. This is just a random point in the entire plane, and this is a directrix represented by red pins. This is an explanation for the entire project. These are the four possible outcomes of any parabola.